Yes, just friend, in this video I will be explaining you compound microscope. You know, simply you have read many books. It consists of two lenses, one objective lens, other eye lens. There are some difficulties in understanding and doing, and every year question is asked, draw the diagram of image formation in compound microscope and explain what is magnifying power. It is also difficult to understand what is magnifying power. So see me how I draw the diagram. Actually, first you draw here objective lens of small aperture. I have to draw it bigger because I want to explain. Otherwise, its aperture diameter is hardly 1 centimeter or less than 1 centimeter radius. This radius. Draw the principal axis. Now write it as objective lens. Now its working is that when its focal length is small, when object placed between f and 2f, mark here first f and 2f, both sides. These distance will be equal. Put the object here, small object, not big one. Draw ray parallel to principal axis through focus and then through optical center. So the ray go like this. Put the arrow first. Now complete this image here. Now you have to put second lens. Other eyepiece should be there. First of all, draw a dotted line, just this axis of the lens, so that these rays intersect this. Put the arrow here. Then make the lens. Though here the lens appearing very large, it is my trouble here to just explain the diagram. This is the eye lens. Eye lens. Mark here point E. Actually, E is the optical center of eye lens, O is the optical center of objective lens. Now the difficulty lies here. We do not know how to refract these rays, but we know when they are incident parallel parallel to principal axis, they are refracted through focus, and the ray passing optical center goes straight. This is object AB. This is image A dash B dash. Image A dash B dash should lie within focus of eye lens FE here. And mark the distance BO. Distance OA dash. This is optical center O. OA dash equal to BO. Now take one ray through optical center straight dotted line. Because we are taking these as helping rays, nothing else. Another parallel to principal axis. It will pass through focus. FE here, FE this way. And then join this. You see here they are going apart. So we have to produce them back. Produce them back. They will appear to come from this point. Here will be the final image. A double dash, B double dash. Now we have to show how to reflect these rays. We have chosen these ray here to join this point to this with dotted line and produce further. So now there is no difficulty. I have drawn in here in first attempt correctly. And please don't forget, helping rays should be drawn with dotted lines. And right here, dotted line indicates helping ray. In our books, most of the book don't use this diagram. They take I don't know how they are explaining students, and students are in trouble. Now this angle here is beta. Actually, aperture of this eye lens is smaller than I. Aperture of this eye lens and object lens less than I. You might have seen in biology lab microscope to see the slides and other things. And using microscope we see very small objects which are not visible with naked eye. I hope you might have got my point. How did draw? Don't draw first both the lenses. Draw the objective lens, obtain this image, and then draw the eye lens. So you will get it very easily. This question is of 5 or 6 marks. Hardly sometime 2 marks, sometime 1.5 mark. No more than that. So I think there is no need to explain what is microscope. Compound microscope consists of 2 lenses, eye, objective lens, eye lens. Objective lens of small aperture, eye lens of bigger aperture. Focal length of objective is again small, and eye lens large. Question arises, why do we use small aperture of objective lens? Aperture, you understand? Through which area, through which light passes. Aperture means the area of lens through which light passes. So if we take large aperture, then light from small object will spread through large area, and finally image will be dim, not bright. If, on the other hand, if we take small area, small lens, the light will pass through the small area and will produce bright image. Focal length is small because we want to magnify the object AV. Telescope, microscope has 2 objectives. One to magnify the image, and number 2 resolution. Resolution means if 2 objects are placed very close to each other, they are not visible separate, like every solid material has atoms or molecules. There is distance between them, but we are unable to see the distance so small. I told you it depends upon angle subtended by object on our eye. Now, what is magnifying power? How to understand magnifying? AB the object. This is very small, dear students. Here it appears this much. No. It is so small that we can't see with the naked eye. We can't see it with naked eye. So, suppose it is object AB here, before eye, and here is the eye at this distance of distinct vision. Eye, object AB. You draw this separately. In books, actually, I can't say what they have done. So this is the object AB, this is angle alpha maximum. While starting microscope, I told you visual angle. It is a visual angle which make the object appear smaller or larger. Small objects cannot be seen by naked eye, but we assume that object A be placed at distance d. So angle subtended by object AB on eye is alpha maximum because it plays at d. Now magnifying power of compound microscope. This is important thing. Magnifying power. Of compound microscope. We write by capital M is equal to angle subtended by final image on eye when seen through microscope divided by angle subtended by object on naked eye when placed at D, least distance of this region. ये figure 1, ये figure 2. In figure 1, actually beta is the angle subtended by final में A double dash B double dash on the objective eye lens. It is on the angle subtended by object on objective lens. Since eye is kept very close to lens, so beta supposed to be angle subtended by. Please make a note of it. Beta here is the angle subtended by final image A double dash B double dash on eye lens. Since eye is kept very close to eye lens, so beta may be taken as the angle subtended by object on image on eye. From figure 1, beta equal to tan beta equal to A dash B dash upon E A dash from figure. From similar triangle, this is the angle same. We have written like because since beta is small angle. I have told many times when theta is very small, theta tends to 0 means theta is small, and this approximation is true up to 15 degree, 10 to 15. Beta is small, and similarly alpha maximum from figure 2 is equal to AB upon D. AB upon D alpha maximum. So M is equal to M capital M magnifying power, not magnification, magnifying power. Beta upon alpha. Beta is A dash B dash upon E A dash. When we divide this here, they get inverted D upon AB. I hope you understand what. By this upon this, when you divide x by y, तो you write x upon y, तो ये upon में है, तो उल्टा हो गया. और it is equal to AB, A dash B dash upon AB into D upon E A dash M. Magnifying power, angular magnification. Equation 1. Now, this is U sorry. This much. And this is UE. Actually, for eye lens, A dash B dash, image A dash B dash act as object, light within of focus light focus of the eye lens. Now in figure 1, triangle ABO or A dash B dash O, similar triangle ABO. A dash B dash O similar to A dash ABO, and hence A dash B dash upon AB equal to OA dash upon OA. Sides of similar triangle are proportional. OA dash is equal to BO upon OA minus U. अब here U and B are treated as known values, and therefore in equation 1, putting this value in equation 1, we get M is equal to minus BO over UO into D upon EA dash. EA dash. What is EA dash? That is minus UE. Using EA dash minus U and D equal to minus D, because light going this way, we get M is equal to minus BO over UO into minus D upon minus UE. E क्यों लगा? Object distance for I length, और M is equal to minus BO over UO into D upon UE. This is the general expression for magnifying power. In almost all the books, this image A double dash B double dash in figure, in their figure is shown at D. No, this image may be anywhere, varying from infinite distance to D. What I said, कि image A double dash B double dash, this image, it will be dotted line here. In almost maximum books, it is shown at D here. No, it may be anywhere between infinity and D. Image formed by I lens may lie anywhere between infinity and D. Now, for maximum angle subtended by object or image on I, when an object will subtend maximum angle when it is at least distance of distinct vision. So, if image A double dash B double dash is formed at D, number one case, maximum angle measure के लिए, when A double dash B double dash when final image A double dash B double dash is formed at least distance of distinct vision from I. Who forms this image? I lens. Then for I lens, image distance BE is equal to minus D, UE is equal to minus UE, or F is equal to FE. Using the lens equation, what is lens equation? 1 upon V minus 1 upon U is equal to 1 upon F. So here minus 1 upon D minus 1 upon minus UE is equal to FE. And therefore 1 upon UE, 1 upon I should write here 1 upon D plus 1 upon Fe. Using this value of U in equation 1, what is that? M equal to minus VO over UO into D upon UE. Here 1 upon UE use करेंगे हम. So we get, using this value of 1 upon UE in equation 2, we get, you can write using in equation 2, M is equal to minus VO over UO into D bracket 1 upon D plus 1 upon Fe, or M is equal to minus VO over UO into 1 plus D upon Fe. This is the maximum value of angular magnification produced by compound microscope. This is the maximum value of magnifying power. Here, dear friend, in one sense, A dash B dash upon AB. Here, A dash B dash upon AB may be called as magnification produced by objective lens. 1 plus D by Fe. ME, linear magnification. So, this also used. Minus MO into ME. Small magnification, which is called linear. Product of linear magnification produced by eye lens and objective lens. In this case, distance between two lenses, which is called length of microscope, L equal to VO plus UE. VO plus UE is the focal length. Now, if this final image A double dash B double dash is at infinity, वो कब होगा? When any lens forms the image object at infinity, when it is at its focus. So for least magnifying power, final image is at infinity, and therefore U equal to Fe. Then M is equal to minus VO over UO into D upon Fe. This will be the least magnifying power of compound microscope. Further, there you may think that focal length of objective lens is not used. Actually, VO and UO depend on focal length, which is small. Object placed very close to lens of focus, and it will form real inverted image when object is F and 2F. Here FO or 2FO. So, object focal length of eye lens taken is small, so that for small u, there should be large V, just to obtain large angular magnification. In this case, L equal to VO plus Fe. Many questions are asked on this topic, and please draw the diagram 2 times or 3 times. You may also be asked the diagram when final image at infinity means for relaxed eye. For relaxed eye, how to draw diagram? वीडियो थोड़ा लंबा हो जाएगा, लेकिन मैं आई एम डूइंग हियर. ऑब्जेक्टिव लेंस F to F to F. Here the object is small, and this is the through principal axis of focus. Here you get larger image A B A dash B dash. Now, when final image at infinity, this image A dash B dash should lie at Fe. So you draw a diagram of objective lens like this. Pass this ray through optical center, take parallel ray, use focus such a way that after reflection they become parallel. So these rays become parallel. Then draw these as parallel passing through this here. And then this will be at infinity. Objective and eye lens. You can write here FE, this VO, and now this is FE. Please remember the diagram and put the arrows necessarily, otherwise mark will be deducted. So don't draw both the lenses first and then start showing image. No, that is why this is not home. Thank you. We will be coming for numerical in next video.